grade 12's. Good morning. This is Patrick Kamala trying to get hold of you. Now, in our previous video, we looked at the sums of the arithmetic series. Today, we are going to look at the summing the terms of a geometric series. Okay, we're going to look at what? Summing the terms of a geometric series. I'm sure if you enjoyed our previous video, you will like this one too. Okay, let us start. Now, a geometric series is the sum of a geometric sequence. So, if this is our geometric sequence, a geometric series is this one like this. That means 3 plus 6 plus 12 plus 24 and so on. So it's called a geometric series. Okay. So in other words, the sum of a geometric sequence gives us what we call as what? A geometric series. Okay. Now to get this sum, we will use the formula below to calculate the sum of the finite geometric series. Okay. So we can write it as Sn equals to A open brackets R power n minus 1 divided by R minus 1, whereby the constant ratio R is not equal to 1. So, meaning that the sum of the first n terms of a geometric series is given by the first term, open brackets, common ratio or constant ratio to the power n minus 1 divided by common ratio minus 1. Or you can write it as the sum of the first n terms equals the first term, open brackets, 1 minus common ratio or constant ratio power n divided by 1 minus constant ratio. Again, our common ratio cannot be equal to 1 because it will not be defined. Okay, let us see how this formula come about. Okay, by this formula, you're supposed to know it for examination as well. They can ask it. Okay, now we are saying, where do this formula come from? So consider the following example. Evaluate geometric series that is h6 equals to 4 plus 12 plus 36 plus 108 plus 324 plus 972. And these are 6 terms in total. Now, if I want to know the sum of this series, this is what I do. First, I write my sum, that is the sum of the first 6 terms, as 4 plus 12 plus 36 plus 108 plus 324 plus 972. And that's my equation A. Don't forget my constant ratio is what it is. It is 3 here, because 12 divided by 4 is 3. Also, 36 divided by 12 is also 3. Now, if I multiply by the constant ratio, I get 3 times the sum of the first 6 terms to give me. Now, 3 times 4 is 12, and 3 times 12 is 36, and 3 times 36 it is 108. Then 3 times 108 it is 324, until the last term, that is 3 times 972, which gives me 2916. Okay. Now, after multiplying the series by the common ratio, now I can subtract A. This is equation A minus equation B. And as I do so, because these numbers, they are the same in here, as you can see, it's going to be S6 minus 3S6. That's what you see here. And then this 12 minus 12, I get 0. 36 minus 36, I get 0. And then 108 minus 108, I also get 0. And then 324 minus 324, I also get 0. Until 972 minus 972, which is 0. So I'm left with actually 4 minus 2916. So it means I'm going to have 4 plus 0 plus 0 plus 0 plus 0, then minus 2916. So if I say 4 minus 2916, I get negative 2912. Likewise, if I say here S6 minus 3 S6. Now these are like terms. It's like saying 1 minus 3, which gives me negative 2 S6. And because I'm looking for S6, which means the sum of the first 6 terms, I divide by negative 2 both sides. So if I divide by negative 2 here, I get 1, 4, 5, 6. So this is the sum of the first 6 terms of that geometric series. Maybe you can say, why do it like that? Because I want to generate a formula whereby we do it following the same procedure like you see it here. Okay, let us proceed. You're going to understand this much better. Don't worry about it for now. Okay, now the above method can be used to derive the formula for the sum of the first n terms of a geometric sequence. So we have a theorem here, which is theorem 2. The first one was for the arithmetic. Now if we have, it says the sum of the first n terms of a geometric sequence is given by the formula, saying that the sum of the first n terms of a geometric sequence is given by the formula, which is Sn equals to A, open brackets, r power n minus 1 over r minus 1, which would also be Sn equals to A into 1 minus r power n divided by 1 minus r, whereby the common ratio cannot be equal to 0. Now this is our proof here. Now let the first term of a finite geometric series be denoted by A. So this is our first term, which is A. And then let r denote the constant ratio, or called common ratio. And then it means that our sum of the first n terms is going to be given by this one here. Okay, so as you can see, I have my Sn, meaning the sum of the first n terms equals to the first term plus the second term plus the third term plus the fourth term plus so many terms up to the last term, which is A r power n minus 1. So this is my equation A. Now again, like I did in the previous example, I multiply the series by the constant ratio. So the constant ratio times Sn, that's what you see here. Then constant ratio times the first term, it gives me AR. Then again AR times R, it gives me AR squared. Again AR squared times R, it gives me AR cubed. And again AR cubed times R, it gives me AR power 4 somewhere here. Up to the last time here, which was AR power n minus 1 times R, it gives me A to the power AR to the power n. Don't forget that when I am multiplying and I have the same bases, I add the exponents. What am I talking about here? Let me show it properly. Now this was AR power n minus 1. Now times R. Okay, times what? R to the power 1. So because I have the same base as R, I'm going to have it as what? As A, then R to the power n minus 1, and then plus what? Then plus 1, because we said when you are multiplying and you have got the same base with exponents, you do what? You add the exponent. So now negative 1 plus 1 gives me 0. That's why my answer is left as what? As A r to the power n. Now again, if I subtract b from A, this is my equation A, this is my equation B. This is what happens. Okay. Now like we did in the above example, we saw that the middle terms, they cancelled out. Okay. If you take this out again, you can see that I'm subtracting b from n. This is b from A, which means it's going to be A minus, there's nothing here, then AR minus AR, they cancel out again like we did in the previous example. Then AR squared will cancel with AR squared here. Then AR cubed is going to cancel with this other one here. and so on. Now the last one here is going to cancel with the previous one, which is this one here. So I'm left with the actually a minus ar to the power n. So that means if I say Sn minus Rsn equals the first term a plus 0 plus 0 plus 0 plus so many plus 0 up to minus ar power n. That's a minus b. Now if I take this out, I see that this a is constant. It is here and also here. Okay, so another is a common factor, so I factor out the a. And even here, my Sn is common. It's a common factor. That's Sn here. So it's a common factor. So if I take it out, I'm going to be left with Sn, open brackets, 1 minus common ratio equals to a, open brackets, 1 minus common ratio power n. So because I'm looking for Sn, I divide by 1 minus common ratio, which gives me my answer as Sn equals to a, open brackets, 1 minus r power n divided by 1 minus r. That's how we prove this formula. Don't forget that my r cannot be equal to 1. Okay. Now similarly, by subtracting Sn from Rsn, the following formula can be derived as well. So it will be Sn equals to a, open brackets, r power n minus 1 divided by r minus 1, whereby r cannot be equal to 1. Why? Because it will be undefined. I hope we are together. Let us proceed and perhaps look at some examples. Okay. Example 24, it says that find the sum of the first 12 terms of the series, that is 2 over 3 plus 2 plus 6 plus so many. Now here they've told us that there are 12 terms, so it means we are very lucky because we know the number of terms. So we need S12, that is the 12 terms. So what's our common ratio? We can say 6 divided by 2, which gives us a 3. That's why the common ratio is 3. And then our first term is still 2 over 3, which you see here. And then I'm looking for S12. So the formula says that the summation Sn of all the terms in a series given by common the first term, open brackets, r power n minus 1 divided by r minus 1. Okay, so if I do substitute, my common ratio was 3 because I'm looking for S12, my common ratio is 3, say my n is 12 here, then minus 1 over 3 minus 1. So with the calculator and with these correct substitutions, I get my final answer as S12 equals to 177,146,6 recurring. Okay, let's look at another example. So in that example, we had the number of terms given to us. Now sometimes we need to find the sum when the number of terms is not known at first. For example, here they calculate the sum of the following finite series, that is to say 0,25 plus 0,5 plus 1 plus 2 plus so many, then plus 256. Now the 256 in this case is our last term. Okay, it's our last term. So from the given information, we see that we can get our first term, which is 0,25. We can get our common ratio by dividing any consecutive terms, that is to say 2 divided by 1. It gives our common ratio as 2. Okay, and then we can get the number of terms using the last term here, because we know that for any geometric, the nth term of geometric is given by what? By Tn equals to a times r power n minus 1. So the nth term is given by a, the n times common ratio, okay, power n minus what? N minus 1. So in this case, I want to get my number of terms. I know the last term, which is 256, so I do substitute. And when I do so here, using this formula here, it's going to be 256 equals to a, which is 0,25. My common ratio is 2, then power n minus 1. Okay, so if I divide by 0,25 both sides, and simplify this, I find myself getting something like this. I get 1024. Now 1024, if I get the prime factors, it's going to be the same as 2 to the power 10. So now you have, because I have the same base, which is 2, I can equate what? The exponents, right? I can equate the exponents. So n minus 1 equals to 10, which means my n is going to be 11. So therefore, there are 11 terms in the series. There are how many? There are 11 terms in the series, okay? That's my answer there. I hope we are together. I hope we are together. If you're not together, please, you can pause the video and watch it again. I'm sure you will understand. Now, in order to calculate the sum of the series, either one of the two formulae may be used. So we can use either this one or the other. So it makes no difference as long as you have got the correct substitutions. Okay. Now, after getting the number of terms, which is 11, the formula says Sn equals to A, open brackets, R power n minus 1 divided by R minus 1. Now, because I know that I'm dealing with 11 terms, I'm going to find S11, okay? So S11 equals to my first term, which is 0.25, then 2 power n, which in this case is 11, then minus 1, over 2 minus what? 2 minus 1, okay? So if I simplify this, I'm going to get my answer as what? As S11 equals to 511,75. So the same method this side, the other method this side also works out, okay? As you can see, this I'm saying 1 minus R power n, my n is 11, divided by 1 minus 2, and still get the same answer as what? As 511,75. Okay, now another example which is interesting and which examiners like most. It says that calculate the summation from I equals to 0 up to 19 of 3 multiplied by negative 2 power I minus 1. Okay, so now in here we're going to first generate our series beginning with I equals to 0, 1, 2, 3, 4 up to 19. Okay, now with I equals to 0, what do I have? I'm going to substitute. When I do so, I'm going to have open brackets 3 multiplied by negative 2 to the power 0 minus 1. So this will give my first term when simplified. Okay, now after 0 I got 1. That's why I have here 1 minus 1. So it's going to be 3 multiplied by negative 2 power 1 minus 1. Then next I'm going to get 3 multiplied by negative 2 power 2 minus 1, and so on until I go to 19. So it's going to be 3 multiplied by negative 2 power 19 minus 1. Now somebody can say, do I have to do so many terms here? Now as long as you can do the first 3 and the last term, then you will be in a position to know the type of the series. Okay, in this case, after simplifying this one here, we get negative 3 over 2, then plus 3 plus negative 6 plus so many until the last time, which is what? Which is 786,432. Now this is my last term, and I have the series, and I have the lower limit, which is the bottom, and then the upper, which is 19. So I can get my number of terms. I hope you guys remember what we said. To get number of terms, we said you do what? We said number of terms is going to be the same as the upper limit, which is 19, minus 0 plus 1, so that I can get to know the sum, which I'm finding out here. So it's going to be 19 minus 0 plus 1, so that I get how many terms? I get my n as 20. So it means I'm going to find S20 for this particular series. Okay, any questions? I hope we are together. Let us proceed. Now to continue with this example, we have seen that the first term is negative 3 over 2. The common ratio is negative 2. Let's check it again. Common ratio. Now check here. If I divide negative 6 by 3, I get negative 2. If I divide what? Negative 6 by 3, I get what? I get negative 2. So it means that negative 2 is what? It's my common ratio. So that's how I get the negative 2, guys. Don't get lost. Don't get lost. Let us proceed. Okay. So now after knowing the common ratio and the first term, and I'm looking for how many terms. We said they are 20. This is how we get it. We said top minus bottom plus 1. So I can find my S20. Don't forget my formula for the geometric series. It is Sn equals to A, open brackets, R power n, then minus 1 divided by R minus 1. So I do substitute in my formula, and I get something like this one here. So I get this one here. Now I advise you to punch everything which you see here on the calculator as you see it here to avoid errors. So when you do so, surely you're going to get this answer, which is 524,287,5. That's the sum of the first 20 terms of that series. Now sometimes it can be more interesting, whereby you have to find n when the sum is given. For example, they say how many times of the geometric sequence negative 1, 2, negative 2, negative 4, 8, and so on will add up to 3, 4, 9, 5 to 5. Listen again. They give us the sequence, and they say it must add up to, will it add up to what? Up to 3, 4, 9, 5 to 5. Now this number here is known to the last term, but is the sum of those terms all together added. Let me say it again. The 3, 4, 9, 5 to 5 is not our last term, but it is our what? It's our sum of all the terms in this series when they're added together. So we need to find out how many terms are they gonna be. Let's check it out. Okay, now if you take our given information, we can find out that in this case our first term is negative 1, which you see here, and then 2 divided by negative 1 gives us negative 2, which comes out to be our common ratio. And then we are looking our Sn is the 3, 4, 9, 5 to 5. So what does the formula say? We set the formula, which is Sn equals to A, open brackets, R the power n minus 1 over R minus 1. And when I do substitute, I have my first term as negative 1, I have my common ratio as 2, then power n minus 1 divided by minus 2 minus 1. So minus 2 minus 1 is negative 3, and then it's negative 1 here. So negative 1 divided by negative 3, the negatives cancel. So the negative 3, or otherwise you can multiply it with this other side, which gives you 3, 4, 9, 5 to 5 times negative 3 equals negative 1 into negative 2 power n minus 1. So divide both sides by what? By negative 1, and simplify to give you 1048575 equals to negative 2 power n minus 1. And this minus 1 is negative, so it becomes positive. This side to make it a 6 here, the 576. So now note something here, that because I'm looking for my n, I'm going to get the prime factors of this 1048576, and when I do so, I get 2 to the power 20. And because the 20 is an even number, it means that also the negative 2 to the power 20 will be the same as 1048576. Let me say this again. on my calculator, I prime factorize this number here, which is 1048576. Now when I do so, it gives me 2 to the power 20. But however, because the power is a positive, is an even exponent, it means even the negative 2 to the power 20 will give me the same value, which was 1048576. And now if I compare the bases, I get my exponent as what? As n equals to 20. In other words, the first 10 terms must be added to give us the 34955. I hope we are together. Let us proceed. Another example here, they say determine m if the summation from k equals to 2 up to m of 1 over 15 multiplied by 3 power k minus 1 equals to 24 and 1 over 5. Solution. Now the sum of the series is given, so we are required to find the number of terms that should be added to give a sum of what? Of 24 whole numbers and 1 over 5. So what do? We write it out again, starting with our lower limit, which is 2. Our bottom is 2. So means we're going to have 1 over 15, then open bracket 3 power 2 minus 1. After the 2, I go to 3, that means power 3 minus 1, then to 4 minus 1 here, and summing up the last term, which is m, it's going to be now power m minus 1. Okay, now when I add all these terms together, I must get what? I must get 24 all numbers and 1 over 5. Now when I simplify these ones here, I get 0,2 for the first term, and then second term 0,6, third term 1,8, and so on up to the last term, which remains intact because of the unknown of m, so I can't simplify it here. So now these first 3 terms, they help me to get my first term, which is 0,2, as well as my common ratio. If I divide 0,6 by 0,2, I get 3. That's my common ratio. And then now, to get the number of terms I'm dealing with, it's going to be m minus 2 plus 1. We said top minus bottom plus 1. So I get my number of terms as m minus 1 minus 2 plus 1. So minus 2 plus 1 gives me minus 1. That's why my number of terms remain as what? As m minus 1. Now after knowing the number of terms and then knowing the common ratio and the first term, I state my formula again, and then I do substitute. And when I do so, this is what I get here. So I have Sm minus 1 equals to 24 and the 1 over 5. So the formula says Sm minus 1 equals to 8, open brackets, r power m minus 1. This is my n, minus 1 divided by r minus 1. So I do substitute with Sn equals to 24 all numbers and 1 over 5, and my a as 0,2, and what about my common ratio as 3. So when I do substitute here, now 3 minus 1 is 2, 0,2 divided by 2, it is 0,1. Okay, and then I simplify this one here like this. So if I continue simplifying this, I can see I'm going to be left with actually I can say 2 multiplied by this one here. Okay, then I divide by what? By 0,2, which is the 242. Now 242 equals to 3 power m minus 1 plus minus 1 again. Now the minus 1 becomes positive to make it what? 243 equals to 3 power m minus 1. Again, if I get prime factors of this 243, it gives me 3 power 5. So because I have the same base as what? As 3, it means that my m minus 1 equals to 5, so it makes m to be 6. I hope we are together. Now, thank you so much for watching. Try this exercise here. It continues. continues. It still continues here. Try it out and don't give up. After trying out the exercise, please, you can check out your answers. You can check out your answers here and mark yourself. These are the answers here. These are the answers here for the exercise. Okay, so I hope you enjoyed the video. If not and you have any questions, you can call me on 0785 222 041. Catch you again in my next video. Bye bye.